Okay, let's go ahead and get started today. This is class 5. We're going to be talking about flow control, at least getting started with it in this class. Also be aware that there's going to be a quiz that's posted as well. So be ready to take that before the end of the day as well. All right, so let's go ahead and dig into this. So flow control, before we do that, here's a review of what we're going to cover today. A review of a few things, some additional assignment operators that we didn't cover previously, flow control statements and comparisons, decision statements, looping statements. At least conceptually, we're going to focus a lot on the decision statements today. We'll do looping statements next class. And we're also going to look at this concept of importing modules, which allows us to load code from libraries. So let's go ahead and get started. All right, so quick review. So the review here, quickly, that I want to discuss is we talked about arithmetic operators. Here they are listed here. I'm not going to go over them all again. And remember that the order of operations applied to this, just like it does in algebra. So the Python interpreter is smart enough to know to do these in the right order, following order of operations, multiply, divide, plus, minus, exponentiation, modulus, which gives the remainder of a division, slash slash, which gives us an integer division, the whole number part of a division, and then parentheses are used for grouping. And then it uses the same order of operations you're used to from algebra. We also had some functions that we went over. Here's a list of some of them here that we went over: absolute value, integer, convert to an integer, convert to a float, meaning a decimal point number, convert to a string, take the power, which is the same as exponentiating, convert a number into the actual ASCII character, convert a character into the number of the code that goes with it. So these are kind of opposites of each other. And then convert some number to a hex string, convert a number to a binary string. And then this input, which allows us to have a prompt that prints out, have the user type some stuff in, pull that in, and store it in a variable. All right, so those are all things that we saw in the previous lecture. And one final thing we saw last time was this concept of variables, which in programming is really a name that's assigned to some data object that's stored in memory. It allows us to take advantage of the computer's ability to remember things for us or store things in the memory. Remember, that was an important part of the computer system, was that giant array of memory locations or bytes. This allows us to take advantage of that. And to create a variable using an assignment statement, we just use the equal sign. X equal 10.5, name equal player, score equal 100. And then to access those variables, we just use the name like we are down here. So name will go into that and pull out the value. Score will go into that space in memory and pull out the value. And as a review of that, the variable names can hold different types, or variables can hold different types of data. You can have a lot of different variables, however many you need, given the limitation being the memory that your computer has. Variables can be reassigned, so if you stick a value into a variable like score, you can change it to another thing later on. And the assignment state, remember, just you give it a name, single equal sign, and then whatever data we want to stick into that. And the data item here could be a number, could be a string, could be a lot of different things. And we looked at the rules for the variable names. Has to start with a letter or underscore, can only contain letters, underscores, and digits, can't be the name of a Python keyword, and they're also case sensitive. And so here are some assignment examples down here, similar to the ones we saw before. Score equals 0, gold equal 1,000, name equal player 1, x equal 10, and so forth. Okay, now the normal assignment operator is shown up here at the top, x equal 10, but there are some other ones we didn't cover last time, so this is now new material. So the new ones are what are called modifying assignment operators. And what they allow us to do is not to create a variable like we have here and put a new value in it. They allow us to change a value that's already in a variable. And here's one that you'll probably end up using quite a bit. This is the plus equal operator. So x plus equal 1 essentially says take what's already in x. X already has to be defined. But it says take what's already in x and add 1 to it and store it back into x. In other words, if x had 10 in it and we did x plus equal 1, after this statement, x would now have 11. And if we go around and we do that again, then x plus equal 1, it would then go to 12. And the next time it would go to 13 and so forth. And so imagine that you're playing some kind of game, and how does it keep track of what level you are? Well, when it's time for your level to increase, they have some variable, they add 1 to it, store it back in there. Now notice you could do this in a slightly longer way. We could say x equal x plus 1, and notice this kind of illustrates that programming is not like algebra. Like this would never make sense in algebra. X is equal to x plus 1. Well, that would always be false. You could never have that equation be satisfied. But in programming, it makes sense because the equal sign is not a quality like it is in algebra. The equal sign here essentially means assignment. So we're saying take what's in x, add 1 to it, and then reassign it back to x. And you could do that this way or this way. In Python, this top one is preferred because it's less stuff to type. And it's also a little more efficient because we're not having to fetch what's in x, add 1 to it, and then restart. We can just say, hey, go to x, add 1 to what's already in there. It really doesn't matter too much which one you use, but this is preferred since there's an operator especially for it. Now, there are some other modifying assignment operators as well. Instead of just plus equal, there's also minus equal, times equal, divided by equal. And they do the same thing, like minus equals subtract whatever is over here. And these don't have to be constants. This could be any expression over here. It could be other variables. It could be something other than 1 and 2. But notice that x times equal to would double what's in x. X divided by equal to will cut the value of x in half. And we could change these numbers to be whatever we want over here. There are some other ones, mod equal, exponentiate equal, meaning times times equal, and divided by divide equal, which is kind of an integer division. And there's some other ones we're not going to worry about right now that we'll look at later in the semester. Note that the modifying assignment operators are most useful for modifying some variable that already exists. So, for example, you shoot your weapon, you want it to lose 1 ammo. So you might have ammo minus equal 1. You complete a level, you want to go to the next level, plus equal 1. You maybe lose a tiny bit of your velocity due to friction. You might have x times equal 0.99. So your speed, so instead of x might be velocity times equal 0.99, 0.99. That would shrink it by 1%, and the next time maybe shrink it by 1%, so something slows down. So these have a lot of uses for changing something that's already stored in memory. Maybe your score, you get something worth 10 points, score plus equal 10. So these are actually very useful to know and remember. Now, the main topic that I want to get through today is flow control. And what flow control is, it gives the programmer the power to harness the CPU for making complex programs. And when I say complex programs, it's programs that kind of make decisions on what to do or how to react to some situation. And you'll notice that that happens a lot in games, that you have to have the program itself make a decision. Did the player die or did they survive? Did they take damage or did they not take damage? Did they complete the level? Did they not complete the level? And we're going to take a look at a few of those examples, but there are two main types of flow control statements. Decision statements, which are often called branching statements. And the reason they're called that decision is it's deciding whether to do something or not do something. And that's also called branching because it allows the program flow. As the program is running down through the code, it can decide to skip over something before continuing, or it could decide to do one thing or do something else. So for example, maybe a decision in a game would be, you would have the enemy, do they decide to attack you or do they decide to run away from you? Maybe you have the code itself. Did they complete the level or do they need to continue to play? So those are the kinds of things there. So we're going to focus today mostly on decision statements, but notice we're going to come back to these looping statements next class and spend some time on them. But between the two of those are incredibly powerful and are at the heart of creating any kind of complex game that reacts to what we do and does things based on what we do. And that could be as simple as like knowing when the space bar gets pressed, the character has to jump. When they press the A key, the thing on the screen moves to the left. So simple things like those decision statements are very important for simple games, but using decisions and loops in combination with each other can allow us to create incredibly complex games that do a whole lot of different complicated things. Now, decisions in games happen all the time. And hold on, there's a dog barking that needs to go out. Let me pause for 1 second. I'll be right back. Okay, we're back. Sorry about that. All right, so decisions in games, as we were saying, happen all the time. So examples would be things like this. If the player's health ever gets to be less than or equal to 0, then it's game over. The player dies. Another example would be if the monster attacks us and we take a hit, then the player loses some health. Their health decreases. And you might notice here, how do we lose health? That would be an example of where we'd have a minus equal modifying assignment. Other example, if the door is locked, then don't let us walk into the next room, or don't let us leave the level that we're on to go to the next one. So we can't access a room if the door is locked and we don't have the key. If we haven't collected enough gems, then we don't complete the level. So think of something there like Candy Crush or something like that. You don't get enough of the things cleared, you don't go to the next level. If bullets equal 0, then don't let the gun fire. So all of those comparisons, you'll notice, have some things in common. They have this if part at the front, and they have some thing that we're checking, and then they have this then part that says what action to take if that's true. So their comparisons they all have a comparison of some sort, and they all have something that we either do or don't do based on whether that comparison is true or not. And so in programming, in Python, being very English-like, being a very high-level language, it kind of follows that same sort of methodology. So looking at that, the if statement in Python allows us to perform that like this. So you basically use the word if, and then we have after that a condition or a comparison, and we'll talk more about those in a second. And then we have a colon, and then indented underneath that, kind of like an outline that you would write for school, you have a list of the statements that go with that if statement. So in other words, if this thing turns out to be true, we do all of the indented things in here. That statement, that one, and we do them in order. If this thing turns out to be false, we just skip over that. So that's going to allow us to create programs that allow us to make decisions about what the program is going to do based on some kind of condition that happens in the game. So in other words, when the monster attacks us, these things happen. Or when we run out of ammo, these things happen. Or when we run out of lives, the game ends. So that's very much like the decisions we make in our daily lives. And that's a really cool thing because it allows us to kind of take thoughts that we would have about what we want to happen and when we want those things to happen, and we can encode those into the game. So for example, it's payday, I have money in my pocket, go to Kroger, buy a case of beer or whatever. So that's a kind of statement or comparison that I would make in my daily life. Or it's the weekend and the weather is nice, so I'm going to go out and take the kayak out on the lake. But notice that that's a comparison. If it's the weekend and the weather is nice, then load the kayak in the car, drive to the lake, put the kayak in the water, paddle around for 2 or 3 hours, paddle back, unload the kayak. So notice as you can have a whole lot of things that are indented underneath this if statement that are all based on one condition, or you could have multiple conditions. That an if statement inside of an if statement. We'll look more at the complicated things later. But the cool part about that is it gives us the ability to take our thought process. There's a little mistake there. Let me fix that. To take our thought processes about what should happen in different situations, and we can get the computer to do those automatically for us. So to me, that's pretty magical because you can say, here's what my thought process is. I'm going to take that out of my brain and put it in the computer, and it's going to do the thinking for me. All right, so let's look at what the comparisons might look like that are in there. And notice back here, I have kind of these square brackets there. Those aren't really there. You don't need those. They're not part of the syntax. It's just showing there's a place there that you fill stuff in. So let's look at an actual example. So here's an example. We say if health equals 0, notice the 2 equal signs there, then that means you've died. Game over. So note that the comparison uses the equal to operator between two expressions. So here's an expression that has a variable. There's one that's just a number. So the equal is the one that's actually doing comparing, are these two things equal or not. So let's look at some of the comparison operators, or conditional operators. So in other words, all of them will separate two different things like we have here. So in other words, health equal 0. Or you might say ammo not equal 0. Or you might say ammo greater than 0. But each of these have two different values or things that evaluate as values. It could be an expression here. But what each of these do is they produce a value that's either a true or a value that's a false. And notice we have this set of comparisons that you're used to doing with mathematical things. So if this is equal to that, then take this action. If this is not equal to that, take this action, and so forth. And notice that each of these will produce either a true or false, and true and false are the kind of special built-in values in Python. And the two sides of that comparison, any comparison operator, can be any valid expression. Could include variables, arithmetic operations on numbers and variables, numeric values by themselves, etc. But you have to put something there because they're all comparison. To do a comparison, you need two things. Is this equal to this? Is this bigger than this? So you need to have two things that you're comparing there. All right, now let's try a few in the Python shell here. And actually, let me just temporarily switch over to a Python shell here. And I'm going to make the font bigger so you can see it a little better here. Give me just a second to resize this. And then we'll switch over to where you can see that. Okay, so let me switch over to where you can see that. All right, so here's my Python shell. So trying a couple of these, if I say 1 greater than 2, you'll notice that it returns false. 1 is not greater than 2. If I say is 2 less than 1, that's also false. But if I say is 1 less than 2, it'll say true. So you'll notice that the built-in true and false values coming out there is 1 equal to 2. False, it's not. But I could notice that on each side of that, I could say is 1 equal to 3 minus 2. And that's true. And so notice it's smart enough to do these calculations on this side and then do the comparison on that side. In fact, I could put a calculation on both sides. I could say is 5 minus 6 equal to 10 minus, or 11 minus 10. And notice that's false because that's 5 minus 6 is negative 1. 11 minus 10 is positive 1. But if I were to change it around and say is 5 minus 6 equal to 10 minus 11, that one's true. All right, so very cool. Gives us the ability to do comparisons like that. Notice that if I try to use a single equal, it'll give me an error. And let's just switch back temporarily and try that error for a second. Word Python. Okay, there we go. So if I were to say is 1 equal to 1, notice that says cannot assign to literal. And the reason for that is, remember we had those assignments earlier, that the single equal is used for assignment, like x equal 10. The comparison operator, remember, is double equal. Now, some of you are going to run into this when you write your program because you're using this. Might say is ammo equals 0. You'll use a single equal sign. That'll give an error when you use it as a comparison. We have to use the double equal for a comparison. All right, so switching back temporarily to this, notice that we can also use variables in those comparisons. So far we've just been using these kind of string or these numeric literals in these things. Notice we can also use variables here. So for example, oops, let me go back. Let me adjust this a little bit since it's cutting off the page numbers at the bottom. Okay, that looks a little better. I thought I had that adjusted earlier, but apparently not. Okay, that looks better. Okay, now in this case, notice we're using variables. So x equal 4, y equal 10, z equal 2. That just creates 3 variables. One called x that's holding 4, one called y that's holding 10, one called z that's holding 2. And now is z greater than 1? Well, it'll fetch the value from z, 2. Say 2 greater than 1. It is, it's true. Is x plus y greater or less than z? So x plus y is 4 plus 10 is 14. Is that less than 2? No, it's not. So that one's false. And this one here, notice you can do fairly complicated expressions on each side. Z raised to the z power. So that z had 2, remember? So is 2 squared plus 4 plus 10, is that equal to 10? Well, let's look at what that is. So 2 squared, 2 times 2 is 4, plus 10 plus 4, that ends up being, or plus 4 plus 10. I think that's not really true. I think that's wrong the way I have this in this document. But the idea is that it'll compute all of this stuff for us and then print out the result. Now let's switch back to the shell and try it quickly here. So here we are back to the shell. So here, let's try a couple of these. So let's say x equal 4, y equal 10, z equal 2. And I can say is x plus y plus z, is that greater than, let's say, x raised to the z? False, it's not. So notice that we can do those fairly complicated things. Is x less than y? Notice this one should be true, and it is. Is x plus y less than y divided by 2? All right, so let's see if we can figure that one out before we put it in there. So x plus y is 4. So x plus y is 4 plus 10 is 14. So we have 14 on this side. Is 14 less than 10 divided by 2? And the answer is going to be 14 is not going to be less than that. So that's going to be false. So notice you can do those comparisons like that. Now what the if statement cares about when we use an if statement. So let's switch back to the So with an if statement, what it cares about is whether this thing evaluates as true or false. So here's an example of a program here. So this is a full program. You could type this in and try it. And you'll notice that in this program, it basically is acting as a bouncer. It says seconds underscore old. Call the input function, say enter your age in seconds. Well, you have to kind of know the age in seconds, I guess. And then you put that into that goes into this variable. Remember, when input reads something in, it reads it as a string. but we're going to want to use it numerically. And since we're going to use it numerically, we're going to convert it to an integer. So seconds old, we use the int function to convert that into a number. And now the seconds old variable is actually holding a number, which allows us now to compare it numerically. Now that is an important concept. We're going to go back to the Python shell here in just a second, and I'm going to talk about that a little more. But now we can say if seconds old is less than 21 years times 365 days times 24 hours a day times 60 minutes in an hour times 60 seconds. So notice we're using the power of Python to calculate this for us. We could have calculated it on a calculator and then typed in that number there, but we're letting it do it for us. So if the number of seconds old that person is less than 21, then we tell them to go away and tell them they're too young to enter the bar. And then we print done there. But notice what this does. If this evaluates as true, all of the indented lines of code happen one at a time, starting with the first one, this, go away, and then you're too young. If this evaluates as false, we just skip over the indented lines of code. So it's kind of like an outline you would have for what you do during the day. You might say, if the light is red, then stop the car and wait for it to change. And then we might have inside of there, if the light is green, then push take your foot off the brake, put it on the gas, and start up again. Or if there's a quiz posted on Blackboard, then take the quiz and do all the things there. If there's not one on Blackboard, don't take the quiz. So you can kind of see how we're putting those decisions into our program. It can decide to do this or decide not to do it. Now, there are other forms of the if statement, and there are 3 of them, and we're going to quickly take a look at those. So the first form of the if statement here is the one we just saw, which is a simple if. And basically it says if some kind of comparison or conditional, do the things that are indented underneath that colon there. Remember, you need the colon. This needs to be some sort of comparison or something that evaluates as true or false. And if that's true, we do this stuff. Otherwise, we just skip over the indented stuff. Now, there's a second form of that we ought to mention, and that's this if-else structure. And basically the way that works is if some conditional, do this thing when it's true, otherwise do this thing if it's false. So rather than just skipping over this, it skips down and does a different part. So if this is true, so this is where we talked about the decision statements being like branching. So we're making a choice between doing this thing or doing this. It's one branch or the other branch, but it won't do both. It'll do one or the other. So for example, we might say if the ammo is 0, or the ammo is equal to 0, then, or let's do it the other way around. Let's say if the ammo is greater than 0, then fire the gun. Otherwise, make a click sound. So in other words, bang, 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 ammo runs out, click, 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 click. So that allows us to have something like that, where there's 2 choices we're deciding between. And notice that indented underneath of these, you can have as many lines in the if clause or as many lines as the else clause as you need to for whatever it is you're doing. So it might be if ammo is greater than or equal to 0, then make the fire the gun noise, ammo minus equal 1 to subtract 1 bullet from it, make the whatever happens in the game so the bullet appears and moves across, starts moving across the screen. And then here in the else, play the click sound, maybe play a little animation that shows nothing happening, whatever. But you can have multiple things in the if clause, multiple things in the else clause. Now, there's one third one here, and that's this form where it's called an if, elif, and then else. But this allows us to check one condition, and if that one's true, we do that. If it's not true, we go on to the second one. If that one's true, we do this. If it's not, go to the next one. So notice that will ripple all the way down. If it doesn't do any of these, then we can finally get to an else clause. And if none of the above conditionals were true, then we do that, take that else clause. And this kind of structure can be important when we have more than one decision we make. So for example, we might say, is our non-player character going to attack, or are they going to talk to us and befriend us, or are they going to flee and run away, or are they going to hide and wait and try to ambush us? So notice there can be more than one action that we would want them to take, and there could be conditions on all those. So for example, if we're super powerful, then maybe they run away. If they think they're more powerful than we are, their health is greater than ours, maybe they attack us. Maybe if they are part of the same clan that we're in, or we're wearing an outfit that matches their clan, then they'll try to be our friend and talk to us. So this gives us the ability to have more than one condition to decide more than just one action or two actions. We can have any number of these as we want. So note that you can have as many of those elif clauses as you need for whatever it is you're trying to do. And you can also don't necessarily have to have an else clause on the end. You could just have elifs, and if none of those happen, then it just won't do anything in the default. But notice that it will always only run or execute one of the indented things, and it'll start at the top and work its way down through them. So if this one is true and a later one is true, it'll only run the first one it comes across. So in other words, this is like a branch that's branching out like this, where it comes to the point and then it decides, do I go this way or that way or this way or this way? But it's definitely going to take one of those branches. How's it going to decide which one? Whichever one's first one it comes to that has a true conditional, that's the path it's going to take. Now notice that can allow us to make these incredibly complex decisions with multiple actions that are possible. Now, one final thing that we're going to cover today is this concept of importing code modules. And Python allows us to load functionality from other files. And that allows us to expand Python to things that are not built into it. And that's a really powerful functionality because it allows us to download a library somebody else wrote, or use a standard library that comes with Python, but it's not part of the language itself, not one of the built-in things. Or we could write our own modules and then use those. All right, to load those into Python, the first thing we need to do is this thing called import. So here's an example, import random. What that does is it says, hey, load the random module from, in this case, the standard Python library, load that up into my program so I can use it. So you can think like a module of a library module is a collection of other objects, other functions. And I like to think of it like a toolkit or a special spell book of things that we're going to open and then use. So in this case, since random numbers aren't built into the Python built-in functions, it's part of the standard library, we have to open that spell book if we want to use those spells that are in it. And so in our case here, to open that, we just say import random. That loads it up so that we can use it. And most of those modules actually just contain code that's already been written for us to use. And a lot of times that code is other Python code that somebody else has already written for us. So very easy to load them up, very easy to use them. Now, once we've imported the module, we can use functions from it. So here's an example. Import random, that'll load it into memory. And once it's loaded up, we can use it by saying random dot, and then whatever function we want from it. So notice the use of that dot in that line. That's kind of like saying in the random module, use the randint function, which gives a random integer in the range that's specified. And notice that it's kind of like the possessive in English. We're saying, hey, the randint function that belongs to the random module, call that and pass it this information. So this is the owner, and then this is the function that's inside of that owner. And actually, in the case of random, there's more than one function in there. So let's just quickly switch back to the Python shell, and we'll take a look at this. Okay, so here, notice if I say random.randint, and I say, let's do 1 through 6, kind of simulating a die, it says random's not defined, and that's because I didn't import it. So to use that, I have to say import random, it now loaded it up. And now now that I've loaded it, I can say, hey, in the random module, use rand int 1, 6. Now, what's this going to result in? Well, in this case, it produced a 4. And let me just cut and paste this and do a few more. Notice that that is generating a random integer between 1 and 6. So if I run it multiple times, I'll get different values out of it. So kind of like rolling a die, like a D6. If I wanted to roll like a D20, I could say, give me a random integer between 1 and 20. Let me cut and paste that one. And as a quick aside here, note that that random module has other functions in it as well. And there's a cool thing that we can do from the shell to look at what's in a function. I could say dir random. It'll show me all of the things that are in there. So you'll notice that here's rand int, the one that we were using. But also notice there's some other ones in here. We're going to see those later on. There's also some stuff in here that we probably is more complicated than we need it to. But notice there's random.shuffle. There's random.choice. We're going to use those later to pick a random choice out of a set of choices. Random.shuffle we can use to mix things up, like shuffle cards. Random.uniform will generate random floating point values or decimal values rather than random integers. But notice that there's also some stuff in here that it uses for this Weeble variate and log norm variate, expo variate. Those are things that it uses internally to do stuff that it does. So we don't have to worry about those. So for right now, the only one I really want you to know how it works is rand int. And essentially what it does, it says create a random integer with this as the minimum and that as the maximum. So we'll get and that's inclusive. So we could get 1, we could get 20, we could get any other integer somewhere in between those two. And that can be really useful for games. And then how that can be useful for games is that also it's going to give us the ability to have games sometimes do different things at different points in time. So in other words, sometimes the enemy might run away, sometimes they might attack. We can make that kind of random in some way or have a probability associated with it. Okay, so let's switch back to the Okay, so we're back to the presentation. Now, one final example here that I want to do that uses random.int along with an if statement to do decision is this kind of coin flip simulation. So notice, since I'm going to be randomly choosing heads or tails, I go ahead and import random. I print out coin is being flipped, ... That's going to show up. Coin equal random.randint, and here I just put 0 to 1, so half the time I'll get 0, half the time I'll get 1. And then down here I use an if statement. Say if the coin is equal to 0, then print heads, I win. Else, if it's not 0, it has to be 1, print tails, you lose. So in other words, if I were to run this program, sometimes it'll say heads, I win, sometimes it'll say tails, you lose, and then at the end it'll say done no matter what. So you'll notice that this Python being like an outline, if I wanted to, I could do other stuff in here. I could say heads, I win, heads plus equal 1 to accumulate the number. Later on we can put a loop around this and flip the coin 10 times and see how many times it came up heads, how many times it came up tails. We'll look at that next class. But notice that we now have a program that we run it. Sometimes it'll do one thing. Sometimes it'll do a different thing. It'll be random. And the random number generator in Python is actually a really good random number generator, meaning that it is very, some random number generators you'll get the same random sequence every time. The one in Python is not like that. You'll get a different behavior every time, and it's very unpredictable. It uses a really cool random number generation algorithm called the Mersenne twister, and it uses the clock by default to seed that random number generator. But it's a very good random number generator, which makes it so that we can write programs that are really unpredictable for like a I don't know, like a slot machine or the generating lottery numbers, or just when we play a game, maybe you get a random maze each time, or maybe the sometimes when you play you get a different behavior from the non-player characters than other times. But we're going to end up using this random thing quite a bit. It's also really useful for, as we'll see later, for things like particle effects, where you have an explosion and things blow up and it kind of random, or fire that kind of the smoke moves in these kind of random ways. It's going to be something we're going to use quite a bit. But notice this import feature allows us to use this functionality without having to write it ourselves. But what's cool is inside of that random module, it's really just Python code that somebody else already wrote for us that we're reusing. And that also gives us the ability, and we're going to do this later on in the semester, to make our own modules and then import those and use them. Okay, so that's all for today. Finish up Lab 1. Make sure to look on the course site for Quiz 2, which should be posted on there for you to take. Make sure to do that before midnight tonight. Other than that, wash your hands, stay safe, and I will see you next class. And we are going to add to our arsenal next class, we're going to add looping structures, which now take us beyond just one single flow down the program that can make decisions or not make decisions, to being able to repeatedly do something. And notice that's going to be very important for games, to have something like a game loop. So that's it for today. Stay safe, and I'll see you soon.